Okay, now yesterday we did this kind of joke assignment. I say joke because there wasn't a lot involved in it. So the absolute value of x is greater than or equal to 4. Make a graphic representation of that and label the graph. You don't need to write this down, okay? Don't need to write this down. This is the packet you're working on. That's a horrible number line, okay? So I put 0, and remember, absolute value is distance from 0, so I put 4 on one side. Now, that's a greater than sign, so we want to get further from the 4. Now, we also have to account for negative 4, and I want to get further away from 0. That's what a greater than means, okay? Now, you label it x4. When it goes that way, it needs to eat the x. But when it goes this way, it can't eat the x. It has to eat the other thing. Now, you notice something happens. The sign switches on the negative. Compare the symbol here to here, it's the same. From here to here, it switches, so remember that. If you remember that little rule that it switches on the negative, you'll be good on this assignment. Now, from now on, when you see absolute value, I want you to make a table, okay, and make a number line. This is how I want you doing the absolute value problems from here on out. What you'll be doing with that sign is writing it the same here, but then flipping it on this side. You're going to do that every time. Now, we don't have anything in front of the absolute value. Like in front, there's no number that I would put a dot with. And after the absolute value ends, there's not a plus or a minus. So I'm ready to go. So on this side, I put x minus 2, x minus 2. And on these sides, I put, remember, absolute value can account for 1 or negative 1. Now you solve them. Wall goes up, 1 dot circle, plus negative. 2, you'd add 2. Divide by 1, so you got x less than or equal to 3. Sign won't flip on hardly any of these because your dot number's positive, so it stays the same. Okay, so plot 3, make a circle, fill it in. Don't put the arrow till you get the second one. Okay, it's a negative 2. So we have a positive multiplying number, so the sign stays the same. If that was a negative 1, I'd flip it. Plus 2, plus 2. Negative 1 plus 2 is 1. 1 dot x. Okay? Divide by 1, I get 1. Okay, so 1 is your other number. Circle, fill it in. And it doesn't eat the x here, so that goes inward this way. It does eat the x here. Look at the board. It goes this way. So it ends up, which is one of less than it's going to, okay? The x, just the x itself. Remember, I don't do 1 and negative 1 because there's other stuff in there with the x. The x has to be solved for. So I put x. It's all about the x now, not just because there's crap in with the x. On yesterday's, there wasn't. So you put 1, 3. You eat the maximum. You never eat the minimum. Okay? Done. Okay? Next problem. Just because it's not an x, it doesn't mean anything. Okay? Make your table. And we put less than or equal, greater than or equal. Okay, anything in front? Nope. Any plus minus behind? Nope. So I have p minus 7 in the absolute value. Okay, and then at 3, you could be at positive 3 or negative 3. Remember, the sign flips when we do the negative side. Okay, wall goes up, 1 dot circle on your p, just like you would with an x, make it plus negative. So we're not going to flip the sign because it's a positive multiplier, so we got 7. So we have 10, 1 dot x. Now divide by 1, we got 10. Okay, so 10 is your critical number. Then my other one, here's the wall. Okay, 1 dot circle, get a plus negative. You're not going to flip the sign because that's a positive. So plus, plus, 4, 1 dot p. Divide by 1, so p, 4 divided by 1 is 4. Okay, so the other one's 4, both positive. You can have them on the same side as 0, that's okay. Here you are not eating the X. Here you are the P, I should say. Here you are eating the P. So I put P and then 4, 10, eat the 10, don't eat the 4. Okay, our next problem. Okay. So in the absolute value, you got 3x plus 1. Okay. I just write that down twice. Nothing outside I have to worry about. Not a dot number here, no plus or minus behind it, so I go with 8. And I use the same sign with positive 8, but then I flip the symbol when I do the negative 8. Okay, now I make the wall and solve. Okay, so minus 1, minus 1. 7, 3. By the way, the sign is not switching after I divide because it's a multiplying positive number. Divide by 3, and we have x. Now let's see what 7 divided by 3 is. 2.3 repeating, okay? You can have that. Okay, positive multiplier, wall goes up, dot here, doesn't flip. So we have negative 9, 3 dot x. So x, negative 9 divided by 3 is negative 3. So I have positive 2.3, and then I have negative 3. So let's talk about positive 2.3. Well, we're not going to fill in the circle because the line's not there. It eats x, okay? It eats the x, so it's going that way. Here you're not eating the x, so you go that way, so they spread apart. When they spread apart, you just copy these onto the label, okay? So just put x less than negative 3, and then the same thing here. That's all you have to do. Don't overthink that part when they spread apart. When they come together, you need to write a minimum maximum. Okay, next up. Wall goes up, and we have the expression 4w plus 1. No dot number, no plus or minus, so we use 11, okay, and negative 11. Use the symbol given with the positive, but then we flip it on the negative. And I showed you why it flips on that very first problem that you didn't have on your paper, okay. Wall goes up, dot circle, won't be flipping. So that's 10, 4 dot w. Divide by 4. Divide by 4, I have w. 10 divided by 4 is 2.5. That's okay. Wall goes up, dot circle, minus 1, minus 1. You just flip the symbol on the negative. Negative 12 and 4 dot w. Now it's dividing by 4. Sign will not be changing because that's a positive multiplier. So I have negative 3 and I have 2.5. Circle, we're not going to fill them in. Does it eat w with the 2.5? Sure it does. So it goes this way. Eat negative 3? Nope. Got to go this way. So I just copy down what I have. W greater than 2.5, and then copy that down. W less than negative 3. Those are possible values for W. Okay. Make the table. Any absolute value problem, we're making a table anytime I see those. So I have 3x minus 7, and just put the same exact expression over here. And we're going to do no dot number, no plus or minus, so I just roll with the 28. Okay, keep the symbol the same, and then you flip it, okay? Okay, so 3x, not negative, okay? You can make the 7 plus negative. Here's your wall. You're going to add 7, add 7. So that's 35. And we have 3 dot x. Now I divide by 3. This is going to be a decimal, that's okay. 11.6 repeating. Wall plus negative. So 7, 7. Don't flip the sign, okay? So that's 3 times x, and negative 28 plus 7 is negative 21. Now we divide by 3. We have x and negative 7. So I have positive 11.6 repeating, and then negative 7. So we're eating the x here, goes that way. But we are not eating the x here, so that it's any value outside of that little inner range. And I just copy them down. So I got x greater than 11.6 repeating, and then x, just copy it, less than negative 7. That's all you do. Okay, need the number line. When I see those symbols, I need a number line to represent my answer. So inside we have 2x plus 9, 2x plus 9. And we're going to use 13 because there are no outside operations. There's no dot, there's no plus or minus after this bracket. Leave it, and then flip it when you do the negative. Okay, remember that. Don't just leave that 13. You got to make that a negative 13. Dot circle, the sign will not change. I have minus 9. That takes that side to 4. Divide by 2. I have x and 2. Wall goes up, dot circle. Sign will not change. Negative 22, 2 dot x, divide by 2, we have x and negative 11. So I have positive 2, I got negative 11. Here it's not eating the x, okay, goes that way. Here it is eating the x, from here it goes this way, and we have a minimum maximum. So I put x just one time, negative 11 and 2. Eat the 2. Just like you are here, okay? And here we eat the x, okay? Eat the x with that one. You always eat the minimum, eat the maximum, but never eat the minimum. Okay, last 2. Hopefully it makes sense. So I got 5x minus 4 and 5x minus 4. So absolute value could be 16 or negative 16, and I keep the symbol when I'm doing the positive, but on the negative, I flip it, okay? Wall goes up, dot circle. So you got 4, you're going to plus that. Remember the sign, the symbol doesn't flip because that's been a positive every single problem. So we got 25 dot x. Then I divide by 5, x and 4. Wall goes up, dot circle. So you got 4, 4. Line, the sign will not change, but I got to add first. It's going to be negative 12, and then 5 times x. Divide by 5. Negative 12 divided by 5 is negative 2.4. So I have 4, and I have negative 2.4. Eats x, so it goes this way. Doesn't eat x, goes this way. So I just copy them down. X less than or equal to 2.4, and then x greater than or equal to 4. Okay, finally I'm at my last example. Okay, inside there I have the expression 2v minus 1. No operations outside, so I'm rolling with 9, negative 9. Keep the symbol the same on the positive, but flip it on the negative, okay? Because to be, wall goes up, dot circle the v just like you would an x, so we got 1, dot sign doesn't change, plus 1, plus 1. 2 dot v, I should say. If you put x accidentally, that's okay. X, or v, I keep doing it. 10 divided by 2 is 5. Dot circle, plus negative. Line up the sign, so we're going to go 1 positive, 1 plus. Negative 8, 2 dot v. Divide by 2. V negative 4. So I've got 5 and I've got negative 4. Here it does not eat the v, so it goes this way. Here it does eat the v, it goes this way. V, negative 4, 5. We got to eat the maximum every time. Here we eat the minimum.